Welcome to the math classes. Today we will learn one important concept in polynomials. Okay, this is called the Descartes rule of signs. Okay, this gives us understanding of number of real roots, number of positive real roots, number of negative real roots, and number of complex roots. Okay, so let's learn this very simple concept which can help you a lot in your entrance exams. Okay. This is my channel here. Please join the channel and more such tricks you can learn from this channel. Okay. So let's see what is this rule, Descartes rule of signs. Okay. Descartes rule of signs helps in predicting the number of positive and negative real roots of a polynomial. Okay. Thus, it also helps in finding how many number of complex roots are there. Okay. Okay, we know the f of x is in the form of ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2 plus so on up to some k, right? So how many number of the positive real roots? You check the number of uh, times the sign has changed, okay, for each term. Okay, first term is ax to the power of n. So what is the sign of a? The next term is bx to the power of n minus 1. So is there any change in sign? Okay, is it changing from positive to negative or negative to positive? Then make the test count 1. Okay, similarly, all the terms, how many times sign has changed, you count it. Okay, that count is very important. Okay, that count gives you number of possible maximum real roots. Okay, similarly for negative roots, you need to count. Okay, before counting, you first change your f of x into f of minus x. Okay, substitute x with minus x, and that is your polynomial, and count the changes, sign changes. Okay, once you have these counts, okay, these counts directly don't give you the possible, real roots, number of real roots, but they give you the possible real roots. Okay, each count gives the maximum number of real roots of that type, or positive or negative. Okay, you have two counts here, right? M comma n, if you call them, m is positive, n is negative. Okay, so that count gives you the what is the possible maximum real roots of positive or negative. Okay, the actual number is either that count, or you have to subtract a even number, that is minus 2. Okay, let's say you got the count positive real root count as 7. Okay, so the possible positive real roots can be either 7 or 5 or 3 or 1. That's it. Okay, it cannot go negative, right? Let's say you got a negative real roots as 1. Okay, then it is 1 only. You cannot do 1 minus 2 is minus 1, right? You cannot have negative roots, negative number of real roots, right? So there it gives you the exact number. 1 is the exact number. But if it is something other than that, you need to subtract by an even number and see which one is possible. Okay, once you have the idea, you can uh, understand it very easily. Okay, so let's take an example and understand this method, Descartes rule. Okay, so first is, let's find out the positive real roots. Let the polynomial is x cube minus 4x square plus 5x minus 2. So you clearly we can see there is a change from coefficient 1 positive to negative here, right? First is positive, next is negative, then positive, then negative. So there is a change here. 1, 2, 3. There are 3 sign changes. Okay, so maximum possible real roots, positive real roots are 3. Or it can be 1. 3 minus 2 is 1. Okay, so this is what very important to note down. Don't always assume that 3 is the maximum. Okay, it can be 3 or it can be 1. So if I put it in a table, it looks something like this. Number of maximum positive real roots, number of maximum negative real roots, complex roots, and a total. And we know that this is a polynomial of order 3. So maximum roots can be 3. Okay. So either positive real roots are 3 or 1. So we'll complete this table once we check the negative real roots. Okay. Now, for negative real roots, I said first you have to do f of minus x. So f of minus x is this value, minus x cube minus 4x square minus 5x minus 2. Okay, and the signs are all minus, so there is no change in sign. So there are no negative real roots for this one. Okay, which is fixed. You can be confirmed that if the question comes, how many number of negative real roots this polynomial has, you can confidently tell it is 0. Okay, so in this case, my table is completed here, either 3. Okay, and once if there are 3 positive real roots, there can't be any complex roots also. Okay, because total number of roots are 3. If it is 1, then there is a possibility of two complex real roots, okay, which is 3. But negative real roots are definitely 0. Okay, so this is how this Descartes rule of signs will help you actually in quickly finding out how many positive and negative real roots are there. I think it doesn't take more than a minute to understand how many positive and negative real roots are there and complex. Thus, you can verify with your answer very easily. Okay, let's take another example. Okay, this one, x power 4 minus x cube minus n x square plus x plus 6. Okay, so this is my f of x. Sign changes are positive to negative, negative to negative, which is same. Okay, so 1 already, and negative to positive, one more, so 2. Then positive to positive, it remains same. So total changes are 2. So how many positive roots are possible? 2. Positive real roots possible are 2. Okay. Next possible is 2 minus 2, which is 0. So you keep that also. Okay. Then for negative roots, f of minus x, this f of minus x is x power 4 plus x cube minus 7x square minus x plus 6. Okay. So here sign changes are 1 here and 1 here, 2. Okay. Here also 2 negative roots also possible. 2 or 0, right? So my table looks like this. Either 2 positive real roots for 2 negative real roots and total are 4 because this is order of 4. Okay. Or 2 positive real roots and 2 complex roots and total is 4. Or okay, 0 positive real roots, 2 negative real roots, 2 complex roots, total is 4. Or both positive and no real roots and only complex roots. Okay, all these possibilities are there for this polynomial. Okay, so you may tell, okay, this gives a idea, but how much it is useful. There is one of the entrance exams, engineering entrance exams, I saw this problem, okay, which is directly the application of Descartes rule of signs. Okay, the number of negative real roots of x power 4 minus 4x minus 1 equal to 0. Negative real roots is asking. Okay, how many are there? Okay, let's first find out. You don't need to do actually positive real roots. You don't need to check, but just for understanding the Descartes rule completely, we will just apply that also first. Okay, okay. So first is this one. So sign changes are plus. Okay, I'm considering 0 as plus. You can consider as negative also. There is no problem. Okay, but be consistent in your assumption. Okay, plus 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 no change, and plus 2 minus there is a change here. Okay, plus 2 minus there is a change here. Okay, and after that it is consistent minus. So total sign changes are 1. So maximum possible positive real roots are only 1. Okay, 1 minus 2 is minus 1. You cannot take that. And f of minus x for negative real roots I'm calculating, it will become x power 4 plus 4x minus 1. Okay, so my sign changes are here only 1. Okay, only the last. Okay, there is one sign change. So total sign changes are minus here. So total negative real roots also possibility is only 1. Correct. So maximum possible positive real roots 1, maximum possible negative real roots are 1. So it's very clear, right? Once you know that 1 minus 2 is minus 1, so you cannot take that, right? You cannot have negative number of real roots. Number of real roots cannot be negative, right? It can be either 0 or 1 or something positive number. Okay. So it's very clear from this one that number of negative real roots is only 1. This is the only possibility. So this is the answer actually. You just apply Descartes rule and you got the answer. Okay. So if you see the table what I wrote just like before, maximum possible is 1, 1. So other two should be the complex real roots. Complex roots, sir. Not complex real, complex roots. Okay. So you didn't ask question is about this one. So this is one. Okay. Hope you understand this Descartes rule of signs. It's very useful. Okay, summary is here. Quick way to estimate a real roots. Always test roots using either synthetic division or a graph. Okay, this only gives you an idea basically. Remember, the rule does not always guarantee the number, only possibilities. Okay, so you have multiple possibilities. You choose which one is final answer after that. Okay, thank you.